let's show you an example so you can understand, right? Okay, now we also choose the same matrix in example 1. Okay, A 4x4 matrix 2 1 1 0 4 3 3 1 8 7 9 5 and 6 7 9 8. This is same matrix in example 1. We practice by Gaussian elimination and LU factorization in last week, right? Okay, now we also choose the same example, but now we apply Gaussian elimination with partial pivoting, and we want to obtain the LU factorization with partial pivoting for this matrix A. It's okay? Now, let's practice now, okay? Step 1. Okay, you should know what is the difference. The difference between Gaussian elimination and Gaussian elimination with partial pivoting, just we need select new pivot in each step before elimination. Are you clear? Okay, so that means step 1, we need to consider the first column. We have 4 numbers, 2, 4, 8, 6. Okay, which one has the largest absolute value? Of course, it is 8, right? 8 in the third row. So in first step before elimination, we need to interchange the first row with the third row. Are you clear? Okay, so first we need to choose, okay, new pivot by interchanging first row with third row. Okay, so now you say 2 1 1 0, change to 2 1 1 0 here, and change 8 7 9 5 to here, 8 7 9 5 here, and second row is not change. The last row is not change. It's okay for you? Okay, so the question is how to represent this operation in matrix form. That means here I show you. It means we multiply from left side on A, okay, by the permutation matrix denoted by P1. Okay, P1 is this matrix. Okay, I show you 0 0 1 0 0 1 0 0 1 0 0 0 0 0 0 1. Clear? And how to obtain this matrix? Because it has name permutation, right? That means also interchange first row with third row on identity matrix. Okay, are you clear? So what is P1? I write here. From the identity matrix 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Okay, this is the identity matrix, right? Identity matrix. Now we just interchange the first row with the third row. Now you see, we interchange the first row to here. Now you see, to third row 1 0 0 0, and move the third row 0 0 1 0 to the first row 0 0 1 0. Then we obtain P1. It's okay? That means P1 is also, we use the same interchanges by row, first row and third row on identity matrix. Are you clear? So this is P1. We don't change the third row and the second row and the fourth row. Okay, now you see 0 1 0 0 here, last row 0 0 1 0 0 1. Okay, then actually you can practice by the product rule between the two matrices. Let's show. Okay, for example, let's check. We use first row multiply first column. Then what is the result? 0 multiply 2 plus 0 multiply 4 plus 1 multiply 8 plus 0 multiply 6. That is just 8, right? Okay, actually, you use this row multiply each column. That means just obtain the third row. right? So that is why we can move the third row to the first row, because we multiply 0, 0, 1, 0 here. It's okay? Okay, and what happens for the second row? The second row, we use this row, 0, 1, 0 row, multiply each column. So that means we just obtain the same row, the second row, 4, 3, 3 here, 1 here. It's okay? And now let's check the third row. We use the third row, multiply each column. Okay, because we only have first number is not 0. So that means just move the first row to the third row. It's okay? And here, last row, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, just move. That means we don't move, just obtain the last row. It's okay? So we checked. We interchange the first row with the third row in matrix form. It means we multiply A from left side by the matrix P1. Okay? P1 is obtained just by perform the same interchange rows, first row and third row, on the identity matrix. You will obtain P1. Are you clear? Actually, these are basic knowledge in linear algebra. Okay? I repeat it for you. Okay, I hope you can, understand, right? Okay, now continue. That means we choose the new pivot by 8. Now you see, 8 is new pivot. Now we can consider the elimination. Okay, so that means we need to multiply L1. Okay, remember, L1 is a lower triangular matrix with 1s on its diagonal. Okay, in first elimination, that means we use 8 to eliminate the 3 numbers in the first column. Okay, so we can put the 3 multipliers in the first column, right? It's okay for you? So here, this multiplier minus ratio, right? Minus ratio. Okay, numerator is 4. Actually, should be minus 4 over 8, right? Because 8 is denominator, right? 8 over 4. So it is minus 1 over 2. And this multiplier is a minus ratio. Okay, for the third row. Okay, 2 over 8, right? 2 over 8. So 1 over 4. And the last multiplier is minus, 6 over 8, right? 6 over 8. So it is just minus 3 over 4. Are you clear? 3 multipliers. Okay, one by one. Okay, then we use this L1 multiply A, then we obtain this new matrix. Of course, for the first column, below the diagonal, they are zeros, right? Elimination. And also we will obtain these numbers, elements. Okay, by using, multiplier. This row multiply each column, right? Third row multiply each column, and the third row multiply each column, you will obtain these numbers. Okay, I left it to you. Okay, I hope you can practice by yourself. I cannot compute all the operations. Okay, I haven't I have no time. Okay, to show you in details. So I ask you to practice to check these numbers by yourself. Are you clear? Okay, so this is the first step. Okay, pivoting. Okay, partial pivoting or column pivoting. Choose new pivot 8 and first elimination. Are you clear? Okay, first step, you should know the difference is here. We choose new pivot before elimination. Okay, let's come to the step 2. For step 2, you should note we consider the second column, right? The second column, now, before elimination, you should choose new pivot. So you need to compare the 3 numbers, right? Below the diagonal. You don't need to check the first row, right? Below the diagonal, okay? Minus 1 over 2. But you should know we use absolute value, right? For absolute value, here is 1 over 2. Here is 3 over 4. Here is 7 over 4. Okay, which one is biggest? Has largest absolute value? Of course, the third one, right? The last one. 7 over 4. It's okay? So this number should be the new pivot for step 2. Okay, again, we need to interchange the two rows. The second row with the last row, fourth row. Are you clear? Because we need to choose new pivot. Okay, so by maximal column pivoting, that means we need to interchange the second row with the fourth row. Okay, so again, we need to use a matrix to represent this operation. Actually, again, we can obtain P2, right? P2 by just the identity matrix, right? Interchange the second row with the fourth row. Okay, second row here with fourth row. So that is why here 1 0 0. We don't change the first row, right? But we change third row or second row by fourth row here. So that is 0 0 0 1. It's okay because here. And the third row we don't change 0 0 1 0, but we move second row to the fourth row. So 0 1 0 0. Are you clear? This is P2. This is P2. Okay, we multiply this matrix by P2 from left side. That means we interchange the second row with the fourth row. Okay, so you see, move to here. 7 over 4, 9 over 4, 17 over 4 here, right? Move this row to here. Minus 1 over 2, minus 3 over 2, minus 3 over 2. Clear? Okay, we obtain new pivot. So here, new pivot is 7 over 4. Are you clear? Okay, again, the second elimination. Okay, we need to multiply matrix L2, the lower triangular matrix, with 1s on its diagonal. So you only need to know we have the two multipliers. How to obtain the two multipliers? Okay, they are ratio, right? Minus ratio. Okay, this one means we need to use this pivot, new pivot, right? 7 over 4 to eliminate this number. So 7 over 4 is the denominator, right? Pivot. And this number is the numerator. So it is minus 3 over 4. Are you clear? So now you say minus disappear. Okay? Divided by 4 for both. Okay, no numerator and the denominator. So only 3 over 7. 3 over 7. Clear? Okay, next we use pivot to animate this number. So the multiplier is minus ratio. Denominator is still 7 over 4. Okay, numerator is here. Minus 1 over 2, right? Minus 1 over 2. Okay, so minus disappear, positive. Okay, here and okay, 2 and 4. Here just be 2. Okay, and reverse. So 2 over 7. Are you clear? Okay, now we obtain L2. Then we multiply this matrix by L2 from left side. Then now you see these two numbers are changed to zeros. Clear? And also we can obtain the new elements. These two elements. Okay, first row is not changed. Second row is not changed. We change third row and fourth row. Are you clear? Clear? Okay, so I also ask you to practice, to check, to verify these two elements. By check, you use L2 multiply this matrix to obtain this one. Are you clear? Okay, so this is step 2. Now let's continue. We need to consider step 3. Okay, now you should know before elimination. we need to choose new pivot again, right? Okay, so now we need to compare the diagonal element and the elements below the diagonal. Okay, so only two elements by absolute value 2/7, 6/7. Which one is the biggest, right? Of course, this number, right? Okay, again, we need to interchange the third row with the fourth row. Are you okay? Right? You should know before elimination, we need to select a new pivot. Okay, so we need to interchange the third row with the fourth row. Clear? Here, maximum column pivoting, right? Okay, again, we need to write this pivoting by matrix form. Okay, so by matrix P3. Okay, now you should understand totally how to obtain P3. Again, from identity matrix, right? Using the same interchange rows, E3 and E4. So we interchange the three rows. So we can obtain, now you see, 1, 0, 0, 0, 0, 1, 0, 0. We don't change first row and second row, but we interchange the two rows. So 0, 0, 0, 1 and 0, 0, 1, 0. Clear, right? It's okay for you? Okay, again, that means we interchange the two rows. So you see, this row come here. 0, 0, minus 2/7, 4/7. And this row change to third row. Minus 6/7, minus 2/7. Are you clear? Okay, now we obtain new pivot. The new pivot is minus 6/7. It's okay for you? Of course, I need to remind you, by choosing the new pivot, we use the absolute value, right? That is just to use to change, to select which one has the biggest, largest absolute value, but we don't change sign. Okay for you? But you should know here, right? Okay, still, we just interchange the position, not change sign, okay? Okay, for the third elimination, that means we need to multiply L3 from left side. Again, what is L3? Lower triangular matrix with ones on the diagonal, right? Okay, there is only one multiplier, minus ratio. Okay, denominator still the multiplier, right? The pivot is minus 6/7, the pivot. And because this number is numerator, right? So minus 2/7, minus 2/7. Right? Okay, so minus, so minus 2/6, that is 1/3. It's okay? Okay, so we obtain the new pivot, and the new multiplier by this new pivot. Are you clear? Okay, again, you need to check. You use L3 multiply each column, you will obtain this matrix. You don't change the first, second, and third row. You only change the last row, right? This number should be 0, elimination, right? So you only need to check this number. It's okay? So I also left to you. It's easy to check. Okay, now we obtain U, right? This matrix U. Of course, this U is different from the U obtained in example 1 in last week, because now we use pivoting, right? So we obtain a different U. Okay, clear? Maybe you will ask, okay, we obtain different U. We obtain different. Maybe we will obtain different solution. Okay, now let's firstly to show you. Okay, in last week here, we obtain here. Now you see, last week we obtain U like this in example 1. But now we obtain another U here. Now you see, totally Totally different, right? Totally different. Okay, don't worry about it. Let's finish, okay? Now, in conclusion, these operations can be represented by matrix form, okay? Now,